Businesses often struggle to access the data they need to make informed decisions. That's where web scraping tools can be extremely useful. However, the challenge lies in the fact that each website has a vastly different HTML structure, making the process of creating web scraping solutions time-consuming and complex. By creating a web scraping AI agent, we can automate this process, allowing the agent to adapt to different websites effortlessly and extract data with ease. In this tutorial, I'll walk you through how to build a web scraping AI agent using PydanticAI in Python. If you're new to PydanticAI, PydanticAI is a Python framework that streamlines the creation of production-ready applications powered by large language models. Developed by the creators of Pydantic, the framework emphasizes type safety and modularity, supporting various large language models like OpenAI, Gemini, Llama, and Anthropic. In terms of prerequisites, you'll need beginner to intermediate Python experience and a basic understanding of working with large language models, such as generative AI. The good thing is, no prior web scraping experience is necessary since the web scraping agent will take care of everything for you. Just a disclaimer, this is an entry-level web scraping agent we are going to build. It will work with most of the websites. For websites like Amazon, eBay, Best Buy that use anti-web scraping services like CAPTCHAs, browser fingerprinting, user behavior analysis, scraping those websites will require a more sophisticated tools like Playwright or Selenium, which I will cover those in separate videos. To get started, launch your terminal and run the command showing on the screen. To simplify model creation and for reusability, open your IDE and create a Python file and name it loadmodels.py. In the Load Models module, construct the generative AI model object. In this step, it's really depending on the model provider you're using. I have tried models from OpenAI, Anthropic, Gemini 2, and Llama 3.2. I found that OpenAI GPT-4o and Anthropic Claude 3 Sonnet work the best. I wouldn't recommend Gemini 2 models for now, since the support for structured output is quite poor. Hopefully, Google will improve the framework in future updates. And Llama 3.2 simply won't make the tool call 70% of the time. I haven't really tried OpenAI o1 and o1 mini models, but I think the performance and accuracy will be a bit higher than GPT-4o, given those models are designed for reasoning and is more optimized for tool calling and structured outputs. The downside is those models will be a bit more expensive, but I have a feeling the pricing will go down within the next couple months once o3 release date is announced. And for the web scraping agent, let's start with GPT-4o mini model to see how it performs first. If the GPT-4o mini model fails to perform web scraping tasks, then we'll replace the model with GPT-4o. To create the web scraping agent, create a new Python file and name it webscraping.py. Import the Python packages, like what I am showing on the screen. We are going to use HTTPX and Beautiful Soup to fetch a web page's HTML markup, remove the HTML tags, and return just the text. Pandas is optional, in case if you want to export the output to a CSV or an Excel file. For the record collection, create two classes called product, results, with base model as the base class. Using the base model class, we can easily define the data fields we want to return in the output. And the other benefit is, using the field function to explain the fields, it will help our web scraping agent to make sure it is using the correct field to store the data points. In the product class, define the fields you want the web scraping agent to extract from a web page. Keep in mind that each website contains different data points. Some will be available, some will be not. For the data fields the web scraping agent cannot find, it will simply return none. In this case, I'm only interested in product name, price, and rating count. And to output the records, we will use the results class to return a list of product records. Now, let's create the web scraping agent using the agent class. For the agent creation, give the agent a name, define the target model, system prompt, number of retries, expected result type, and model settings. For the system prompt, I'm just going to keep it general and short. In the prompt, I will instruct the agent to convert the data string, which is the text fetched from a web page, into a list of dictionaries. Then I will provide the steps to generate the output. If you want your web scraping agent to work close to 100% of the time, you will need to refine the system prompt to make it error-proof. But for now, this is enough. For the output, the web scraping agent will use the product and results class to determine what data points it needs to collect and what the output format should be. This is one of the main reasons why by using LLM, we can scrape websites more easily now. Model settings are optional, but typically I like to set the temperature to close to 0 to make the output more consistent and less random. Max tokens determines the maximum token usage an agent can use when generating the response in the completion. It will also control the number of records can be returned. Each model has different capacity for the output it can generate. Make sure to check the documentation first. For this example, I will set the value to 8,000, which should cover more than a few hundred records. If the number of records exceeds the max token limit, you will have to make multiple calls to handle the volume in batches. In PydanticAI, there are two ways we can assign custom functions, which are called tools, to an AI agent. One is via the tools parameter when you create an agent. The other way is using the tool decorator. I personally prefer using the tool decorator as it is more dynamic and can be easily shared among other tools. To fetch a page's contents from a web page, create a function called fetchHTML text with a parameter called URL. On the top, add the web scraping agent.toolplane decorator to add the function to the agent's toolset. Because a web page's HTML source code will not change, no matter how many times we download the HTML page, I will set the retries to 1. Typically, if a website occasionally blocks a request call, you can increase the retries to 2 or 3 in case if the function fails. Inside the function, we will make a GET request call to the URL address from the argument. If the GET request failed, we will return a text message informing the agent that the operation failed along with the response code. Otherwise, we will create a beautiful soup object with the HTML markup, save just the text content as a text file, and return the cleaned up text content in the function output. Basically, when we give the web scraping agent a URL to scrape, the agent will use this function to get the page's text content in raw format, analyze it, and organize it into the format we specified in the result type parameter. This step is optional. In case you want to validate or modify the result before presenting to the user, we can add the result validator decorator to handle the output in the last step. In the validate result function, I am simply checking if the result generated by the web scraping is a results object. If the test pass, returns the result. Otherwise, returns nothing. That's everything we need to do to set up our web scraping agent. Now, let's prepare the procedure to run the agent. Create the main function as the entry point. And I just noticed that I forgot to import the datetime module. Alright, in the main function, create a prompt variable to define the request. In the try_except block, use the web scraping agent run sync function to send the request. From the response, in PydanticAI, when a response is returned, we can use the data attribute to retrieve the output directly. If the data attribute returns nothing, we will exit out the procedure. Otherwise, print the token usage. From this point, it's up to you to decide what do you want to do with the data collected. You can either load them into a database, export to a CSV file, or process the dataset a bit more. In this case, I want to convert the dataset as a data frame to allow me to save the data as a CSV file or an Excel file more easily. Unfortunately, Pandas' data frame cannot convert a base model record correctly. We have to iterate each record and use the model dump function to convert each record as a dictionary. Then we can use the data frame function to convert the dataset into a data frame and export as a CSV file. To test the agent, I'm going to use page containing IKEA's best-selling products. Oops, forgot to provide the URL in the prompt. Let me try again. If we look at the CSV output, using the GPT-4o mini model, it seems we have successfully scraped the data from IKEA's website. Keep in mind that since the web scraping agent is doing the analysis to figure out the page structure in the HTML code, we can give the agent a different URL and it will still work. We no longer need to figure out the HTML structure to write the code to each the information. And that is everything I'm going to share in this tutorial. Hopefully you find this video useful. If you're a Patreon member, you can download the source code from the link in the description below. And don't forget to like the video and subscribe. Happy coding! See you in the next one.